A very warm welcome to my dear students. So today I will be talking about some application oriented concepts which can go into some very important projects, real life projects. And the thing which I want to tell you people is that people who want to design or want to analyze, study microwave components, simulation of different microwave components is basically an integral part of any practical project that you may face in your practical life, real life. So our objective of discussion in this session is basically just that, in which we will simulate and analyze the different results that we can have relating to perhaps the most popular microwave component which is used in wireless communication applications. These are antennas. Now, before I show you the actual process flow of the structure of the mechanism, I will like to take a few minutes to speak about what type of antenna we will go for simulation. Now see, as you must be aware that we can have different types of antennas depending upon the required applications, the required scenario where we will put those antennas to use. As for example, we can say that we have dipole antennas, we have horn antennas, we have reflector antennas, we have Yagi-Uda or log periodic antennas, we have some smart antennas, and so on. The list is virtually endless. But all these types of antennas, they suffer from one major difficulty. That difficulty is that the size of the antennas, the physical dimension, the physical volume of the antennas can be very large. I mean, depending upon the throughput requirement, depending upon how much power we want from them, depending upon how much radiation intensity we want from them, maybe it may so happen that the physical dimensions of the antenna tend to be very large. Again, as you may be aware that nowadays, in the present era of communication, we want compact and more compact structures, so that in a single communication module, we can actually integrate different structures. It may so happen that in the same module, in the same block, we will have to integrate, say, hundreds of antennas. Each of them can have different functionalities. We can have arrays to be incorporated within a particular function block. So for doing that, the major requirement, apart from parametric or performance optimization, the major requirement is miniaturization. That means you have to prepare a structure before simulation. You have to prepare a structure that is the most compact possible under the given situation, so that it can be integrated within a system module. Keeping this requirement in mind, there was a huge revolution in the research, a new avenue of research opened up, and it is still progressing nowadays. And even some modifications, even some sophisticated adjustments, modifications are carried on, but keeping the same idea into mind. That is printed antennas. Within the same dielectric block, within the same PCB, circuit board, you can actually cast different antennas. Suppose, for example, we can prepare or we can cast a dipole antenna on a PCB having the same functionality, but now the structure will be ravishingly small as compared to the actual dipole structure. So the benefit for doing that is we can achieve the antenna miniaturization which we targeted, and at the same time the performance metrics of the antenna, that is not compromised, and even nowadays it is enhanced actually. So we are getting basically two benefits. One, we are making the structure very much compact, miniaturized, And at the same time, instead of getting some low output levels, instead of getting some low throughput, we are actually enhancing the output. So both these can be done provided we can generate a particular, or rather it's better to say an optimum antenna structure.